So good morning students. Today we are going to study a very important chapter of class 10th physics, that is light, reflection and refraction. So starting from the very definition of light, that what is light? Light is a form of energy which gives us the sensation of vision. That means light is that form of energy which enables us to see the objects around us. Suppose here we have an object AB, then we are able to see the object AB if and only if light rays coming from the object AB enters our eyes. Here light rays coming from the point A of object AB into our eyes, and the rays after meeting with each other are producing the image of the object AB. Now this light can be emitted by the object itself or may be reflected by it, depending upon whether the object emits its own light or it reflects the light coming from some another object. The sources of light can be classified into two categories, namely luminous objects and non-luminous objects. Now what are luminous objects? Luminous objects are those objects which emit their own light, which produce light inside its own body and then emit it. Examples of luminous objects would be stars, bulbs, sun, etc. While non-luminous objects are those objects which do not emit light, which do not produce their own light, but they reflect the light coming from some another object. Examples, let's understand it with some example. Examples of non-luminous objects are table, chair, moon, etc. In fact, more than 90% of the objects that we see around us are non-luminous objects, and only 10% of the objects are luminous objects. Now, having discussed about the types and the sources of light, let's study about the nature of light or dual nature of light. So what does dual nature of light mean? Dual nature of light means that light shows two nature, that is particle nature and wave nature. Particle nature of light says that light is made up of particles in the same manner as the objects or the matter are made up of particles, and this particle theory of light was given by Sir Isaac Newton, and which was also known as corpuscular theory. According to Newton, the light is made up of particles, and he named the particles as corpuscles, and the theory was known as corpuscular theory. Later, another scientist came into existence whose name was Huygens, and he proposed that light is not made up of particles. In fact, light is made up of waves. He said that light is not made up of particles. He disproved the particle theory of light that was given by Sir Isaac Newton, and he said that light is not made up of particles. In fact, light is made up of waves, and he called them electromagnetic waves. He said that light is made up of waves, electromagnetic waves, and the speed of electromagnetic waves being 3 into 10 to the power 8 meter per second, and the electromagnetic waves or the light waves does not require any material medium to propagate. Example, if there is a sun and there is earth, then light travels from sun to earth, and it covers a very large distance in the middle part of a sun and earth, where there is no atmosphere. In fact, that is completely vacuum there out there. So he said that light is an electromagnetic wave and it does not require any material medium to propagate. Later, another very famous scientist of the 19th century, Einstein, by his very famous experiment, the photoelectric effect, showed that light is made up of particles. Means he once again proposed the same theory or the same opinion that was earlier mentioned by Sir Isaac Newton, that light is made up of particles. Now there arises a very huge confusion that which scientist to believe, whether light is made up of particles or it is made up of waves. So we are in a very much confusion now. We want its answer, and the answer is lies in the fact that light is actually both particle as well as wave. That is, light shows its dual nature. Dual means two, so dual nature means light shows dual nature. Now we will give some examples of the phenomena to add on it, that how is it justified that light is made up of particles as well as waves. So there are a lot of physical phenomena in our physics. Example, reflection, refraction and shadow formation. These are those phenomena in physics which can only be explained if and only if light is considered to be made up of particles. Reflection of light, refraction of light and shadow formation are those phenomena in physics which can only be explained if and only if we consider light to be made up of particles. On the other hand, there are some phenomena in physics. Examples, diffraction, diffraction, polarization and interference. Interference which can only be explained if and only if light is considered to be made up of waves. So light shows its dual nature. Sometimes it shows particle nature, sometimes it shows wave nature, depending upon the situation. When we want to study the particle nature of light, light shows its particle nature, and whenever we want to study about the wave nature of light, then amazingly light shows its wave nature. That's very I know that's very peculiar, that's very weird type of phenomena, or but still it happens. What can we do? And you will learn about polarization, interference and diffraction in your higher classes. In this chapter we will be dealing with the reflection and refraction of light, and about shadow formation you have already studied in your lower classes, class 7 and 8. You might have studied about the shadow formation. In this chapter we will be mainly dealing about two major phenomena: firstly reflection of light and secondly refraction of light. So let's start our discussion with the first phenomena, that is reflection of light. So what is reflection of light? Let's start with its definition that you have to write in your examination. The bouncing back of light rays after striking smooth shiny surface is called reflection of light. Just suppose that there is a source of light that is producing light, and light from this source travels into this surface, and light rays after striking this surface bounces back in this direction. Then this whole phenomena is called reflection of light. The bouncing back of light rays after striking a surface is called reflection of light. Now, although I have written here smooth shiny surface, but for the phenomena of reflection of light to occur, the surface need not be smooth. In fact, rough surfaces also allow reflection of light. So after we have learned about the reflection of light, you can understand about reflection of light by taking a real life example. Just suppose that you have a tennis ball and you collide it against the wall. Then what happens? The ball bounces back and comes back to your hand and you catch it. In the very similar manner, reflection of light happens. Light rays also undergo same type of bouncing, and that is called reflection of light. But still you can't say the reflection for the ball bouncing back, because it does not follow laws of reflection. We will be discussing about it in the later part of this video. Now let's start our next topic, that is laws of reflection. Now what is laws of reflection? So there are mainly two laws or 2 points in laws of reflection. The first one is the angle of incidence is always equal to the angle of reflection, and the second law is the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Now in order to understand these 2 points under laws of reflection, you will have to understand that what is incident ray, reflected ray, angle of incidence, angle of reflection and normal. So let's start one by one. Incident ray. What is incident ray? So the light rays coming from the source before striking the surface is called incident ray. This portion is incident ray. The light ray after striking the surface, when it reflects back, when it bounces back, then the path or the ray that is formed, that is called reflected ray. Now what is normal? So normal is a line, imaginary line. In fact I should have drawn it with dotted lines, but I drew it with solid lines. So let's consider that this is dotted line. So what is normal? Normal is an imaginary line. Normal is an imaginary line. Normal does not have its existence. It's actually imaginary line that is perpendicular to the surface. So here this normal line is perpendicular to this surface. It's an imaginary line. Now what is angle of incidence? The angle formed by the incident ray and normal is called angle of incidence I. What is angle of reflection? The angle that is formed between normal and reflected ray is called angle of reflection, angle R. Now what does the first law says? The first law says that the angle of incidence is always equal to the angle of reflection. That means whenever there will be reflection of light, it will happen so by following the first rule or first law, which says that angle I equal to angle R. These two angles will have to be equal to each other. Just suppose that the angle of incidence is 30 degree, then angle of reflection would be 30 degree. It can't be 29 degree. That's what I mean to state. The second law. What is the second law? The second law says that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Now students, it becomes a little bit difficult to explain this second law, because I have this plain whiteboard and you are not able to see me. It's only possible if we are explaining the second law in front of a whiteboard, that we are able to explain it, that what is actually plane and what does it mean to be in the same plane for the reflected ray, incident ray and normal. So still I will try my level best to explain the second law. So just try to understand. Let me erase it first. I will try to explain the second law by using the plane of this paper or the board in which I am explaining it to you. Let's suppose that an incident ray is in the plane of this blackboard and the normal is also in the plane of this blackboard. Then the reflected ray will have to be in the same plane, that is this blackboard. It can't be emerging out of this blackboard or going down towards this blackboard. It has to be in the same plane. That is what the second law wants to state us. That is what the second law wants to explain us, that all the three lines, the incident ray, the reflected ray and the normal, will be in the same plane whenever there is the phenomena of reflection of light. Now there is very important point that we need to understand here, that where is the law of reflection obeyed? The law of reflection is obeyed in all cases, that is in all the forms of electromagnetic waves. That is, we know that light ray, electromagnetic waves, who constitute what rays or what waves constitute electromagnetic waves. So the radio waves, infrared radiations, gamma radiations, ultraviolet rays, X-rays and the light ray itself, that is the visible range of light, they all together constitute electromagnetic waves. So the laws of reflection will be obeyed by all the electromagnetic waves, that is light will obey laws of reflection, the 2 points of laws of reflection. Radio waves will obey laws of reflection, infrared will obey laws of reflection, UV rays will obey laws of reflection. Okay, and another waves that are actually not electromagnetic waves, but the sound waves also obey laws of reflection. That is what I have to mention here. Now let's move to our very next important topic, that is plane mirror. What is plane mirror? First we will be learning about its formation, its construction, then we will be discussing about the ray diagram formations and the nature, position, size, properties, and all that. Okay, so let's start with the construction of plane mirror. To prepare a plane mirror, we take a glass and we paint it in the back side of the glass. We paint it, or we coat it with silver. And then in the very outer part we paint it with red paint or black paint. So this is what the construction of plane mirror. Now let's understand why there is a silver coating and why we have painted it with red and black paints. See what happens. Silver is considered to be a very good reflector of light. In fact, it is you can say best reflector of light. Now if we use silver for reflection of light, or if we use silver in place of mirror, if we use silver as a mirror, then it will be very much expensive. It will be very much costly for us. So we don't use silver, but we use glass for physical strength, and we coat the back side of the glass with silver. Then what happens? Light rays coming from this side enters the glass being transparent, and the light rays, when they reach the silver coating, then as silver is a very good reflector of light, then the silver part reflects the light rays in this direction, of course by obeying the laws of reflection. And this is how the process of reflection occurs. Now question arises that why we have painted it with a red or black paint. This is because the silver coating is very much delicate, very much thin. So if we have not painted it with red paint or black paint, then the silver part will be exposed in air and it may suffer scratches, and the silver part may be worn out, as a result of which the mirror will not be able to show reflection properly and we won't be able to look our face on it. So that's the reason behind the mirror getting painted with black and red paints. Now before proceeding with our topic, I would like to explain the types of reflection that I should have explained it before plane mirror, but no problem. I will first explain the types of reflection and then we will move ahead with our topic. Now types of reflection. So there are two types of reflection: regular reflection and irregular reflection. So what is regular reflection? The reflection in which the rays of light which are parallel to each other after reflection reflect back parallelly is called regular reflection. And the for the process of regular reflection to happen, the surface need to be smooth, while irregular reflection is that kind of reflection in which the light rays which were earlier parallel to each other after reflection bounce back not parallelly, unparallelly, is called irregular reflection. Now irregular reflection is also called diffused reflection, or this irregular reflection is also called scattering of light, which we will be discussing in the later part of the video. Now question arises that does laws of reflection obeyed in regular reflection? Question arises that do the light rays obey laws of reflection in case of irregular reflection? Then the answer is yes. Laws of reflection is always obeyed, whether it is regular reflection or it is irregular reflection. In both the cases, laws of reflection is obeyed. Let me explain you how. Here we have incident ray, reflected ray. Here we have the normal and angle I equal to angle R, and the incident ray, reflected ray and the normal are in the same plane. The same thing happens with all these light rays which are incident on this smooth surface. Now here it is clearly visible that the rays are showing regular pattern, so they are obeying laws of reflection. Now in case of irregular reflection, what happens? This is incident ray, this is reflected ray, and here we have normal. Here the incident ray, the reflected ray and the normal are lying in the same plane, and here we have angle I equal to angle R, so the laws of reflection is obeyed here. Here at this point, the angle, the incident ray, the reflected ray, here we have the normal, and all the three lines are in the same plane, and angle I is equal to angle R. Although the surface is rough, it is not smooth, but at point level, at microscopic level, at each point the laws of reflection is being obeyed. Each light ray is obeying the laws of reflection at that point. Okay, so examples, let's study the examples of regular reflection of light. Regular reflection of light occurs in case of mirrors, in case of water bodies, when the water when the water of water bodies is still, in the still water or the stagnant water, you can say, the reflection of light is regular reflex, where the image of your face will be clearly visible if you will try to look at your image in the water body. Irregular reflection occurs in case of objects like table, chair, wall, etc. Means just suppose that you are standing against the wall, you are facing the wall. Now tell me that will you be able to look at your face in the wall? The answer is no. Why no? Because although the process of reflection is occurring there, the process of reflection is happening there, but still you can't look at your face against the wall, because the wall is not supporting regular reflection, but it is supporting irregular reflection. But still there is reflection, because if there would not be reflection, then how will you be able to look the wall itself? So there is reflection, but that is irregular reflection. Now just suppose that you have turned your face towards the mirror lying in front of you, and when you observe your image, when you look at your image in the mirror, then you will be able to see the face, you will be able to see your face along with the mirror itself. Means the mirror will be visible to you, but now your face will also be visible to you. And why your face is visible to you in front of mirror? That's only because there the process of reflection is not irregular, but there is regular reflection. Now I hope you might have understood up to here. Now let me explain you that why sometimes regular reflection and why sometimes irregular reflection occur. So when the surface is smooth, when I am saying that the surface is smooth, then I am saying it at the microscopic level. That is, if the object is smooth at the microscopic level, when you will zoom into the surface, then you will hardly be able to detect the interlockings or the rough part. So that is what being smooth at the microscopic level is. So whenever there is microscopic smoothness, the reflection will be regular reflection. And if the surface is not smooth, just take an example of the wall that I have earlier taken to explain you. The wall, although the wall, no matter what type of whitewash you have applied to the wall, but it is rough at the microscopic level. Although the wall may appear to you to be smooth, but if you will observe it at the microscopic level, then there will be so much roughness in its surface, and the roughness would be like this roughness. Due to this, what happens, the light rays before striking the light rays that are coming from the source of light, when they strike it, then let me zoom it. What's happening here, the surface is somewhat like this, and the incident ray is falling at the surface. Now if we will draw normal here, then how will we be able to draw the normal? Let me explain you. If the line would have been horizontal or plane, then the incident light would have been in this direction, and you would have drawn the normal perpendicular to this surface normal. But students, tell me, how will you be able to draw normal at this point? So the answer is, draw a tangent here at this point, and at this point draw line perpendicular to this tangent. So this will be the normal, and the loss and the incident and the ray will reflect, making equal angle with this normal, as the angle is made by this incident ray. So it will reflect in this direction. Now at some another point, the light ray which is coming parallel to this light ray, let's zoom here, then you will see that here the surface is somewhat like this, and the light ray is coming in this direction. Then you will draw a tangent right here like this tangent, and you will draw a perpendicular line here, and this will be the normal, and you will draw the reflected ray by making equal angle with the normal as the angle made by the incident ray with the normal, because laws of reflection are obeyed here. And the ray will go in this direction, that is, it will go in somewhat this direction. And this is the reason why the light rays which were earlier parallel to each other, after reflection they are no longer parallel to each other. So this is all about the irregular reflection. Whenever there is irregular reflection, you won't be able to see the image due to the reflection of light, because the light rays go in another directions, in different directions, they get scattered and they never meet with each other, and never the image is formed in right pattern. So, and this is why we call this irregular reflection scattering of light, because light is scattered in all the direction after irregular reflection. So this is all about the types of reflection, that is regular reflection and irregular reflection. Now in our next class we will be dealing with the plane mirror, the image formation in case of a plane mirror, properties of plane mirror, properties of image formed by plane mirror, and all that. But till then, go, have rest, study hard, and rock your result. That's all. Okay. Bye. Goodbye. Not goodbye. Bye for the time being. Bye. We'll meet in the next class.